Imagine if you were to try and find the longest word in a 1,000-page book. Before computers were created, humans would have needed to search through every word in the book. With today's technology, computers can go through the entire book and search for the largest word way quicker than humans can. Now, imagine if a technology existed which could find the largest word almost instantly, without having to search through the rest. Through what is known as quantum computing, tasks like these can be completed almost instantly, in the near future. You've probably heard of quantum computing, whether you've seen it in the news or in a science magazine, but what exactly is quantum computing? Quantum computing is a form of computing which uses wave interference physics with quantum particles to compute and run software in a computer. Before understanding quantum computing, it's important to know what a computer in today's world is made of. Computers at their lowest level consist of electronic wires and particles which can take on two values, on, or off, like a switch. Now, imagine a switch that can take on infinitely many values, perhaps a large spectrum of colors. This is how quantum computing works, using a concept called superposition. Superposition is simply the idea of two particles interacting with each other to produce a result. These particles are known as qubits, the fundamental computing units for quantum computers. Qubits can take on many values at once, compared to bits, that take just one out of two possible values at a time. This ability to take on many values at once can make it much easier to calculate large computations quickly, which take much longer with today's technology. Now that you know how quantum computers work, let's look at the limitations of this technology that prevent its widespread use. Qubits are made of charged particles of light, also known as photons, kept at incredibly low temperatures. These temperatures need to be extremely low in order for qubits to function, and achieving such low temperatures requires a lot of power as well as space. Large pieces of equipment, the size of entire rooms, are required to produce the temperature environments needed for quantum computation. As a result, this requires a lot of power, and raises costs, making quantum computers expensive and non-portable in the foreseeable future. Now that you understand the main ideas of quantum computing and some of its limitations, let's look into some of its real-world applications. Current medicine is designed mostly through trial and error. Quantum computing would enhance the process by using very accurate models which would mimic the human body, and can be used to understand how a particular drug affects the body. Machine learning is also aided by quantum computing. Computationally expensive tasks like recognition, especially facial and handwriting, would become more accurate and faster using quantum computing. Machine learning applications, for example a lifelike speech enabler like myself, would gain tremendous speed. Since one qubit can contain two traditional bits of information, qubits can significantly enhance the efficiency of classical computers. In conclusion, qubits could change computing capacity drastically. These new technologies being researched could potentially take up to 100 times as fast as computers today. When quantum computers become commercially possible, problems that were before considered unthinkable may finally become a reality.